Okay, so let's start. It's 10 o'clock. So I will present my talk, High Performance Serverless Java on AWS. Thanks for attending this talk. Yeah, my name is Vadym, and yeah, I have these two passions, Java and serverless, and that's why just thanks for the organizers for inviting me to share some insights. You can contact me via different channels. I occasionally write the talks about exactly the same topic or related topics. But first of all, who is kind of here, at least Java developer, or has its roots in Java development? So only several people, or undecisive. Okay, it's not now related to the talk, but I have two things to celebrate today. Today is my birthday. I won't share how old I am today. Just one day older. And yeah, it's kind of cool to share a bit of my passion being here, but I will also return home to my family. It was the deal that they will see me today. I also have kind of another thing. It's exactly my 100th public speaking activity on AWS related since 6 years. It has been mainly talks, but workshop, podcasts, a bunch of articles. It's not public speaking, but if it matches on the same day, then it's really cool. Okay, we'll jump over this. So let's start. We are all about kind of what's in the Java community on AWS. But let's look at the Java popularity more or less generic. And if you look in the different sources, and there are different things how you can calculate this. It's sometimes about job postings, sometimes about GitHub projects, or something like this. But anyway, it just doesn't matter. You will see that Java is one of the most three popular programming languages. It's just always more or less about Python, JavaScript, and Java today. And under JavaScript, you see all these derivatives of Node.js, TypeScript. It's just everything is more or less there. If you will look into the in more or less the life of Java, serverless developers more or less on AWS, you will see that AWS since November last year support more or less the recent Java version 21. We now have 22 since April, but as you see now that the support of the version 17 took several years. So it has been released, but this long-term version hasn't been supported for quite a long time. We had to stay with 11 and so on. And AWS also has its own fork, more or less, CRaC, that they support much longer the older versions of Java, because after 2 years, after releasing of long-term versions, Oracle more or less keeps supporting it, keeps patching the stuff, and AWS does it on their own. And they take it seriously. If you look what people are working now on this Amazon CRaC, James Gosling, who is more or less father of Java, but you have the people working on compiler, Alexei Shipelev, Roman Kenke, Volker Simon, so lots of people. So the AWS, now I really see they take it seriously. But anyway, Java is a mature programming language. It's a huge community, so many open source projects, but the adoption of serverless looks like more or less it's representative. There are not too many people jumping onto it. So that's, the room is not full, and this is the same that we see in the Java community anyway. Yeah, you see that exact picture. This is the state of report comparison between last year and 3 years ago, and you see, the adoption of Java is growing, but it's still maximal 10% more or less. It's just not more. And you see Python, Node.js is just way above, which doesn't represent the normal popularity of Java, basically. So obviously there are problems that we are talking about serverless, classical serverless architecture, that Java is by far not the most popular choice. And then the question is, of course, what are those challenges? So why is there? And we also face it in the company. So many people still say, cold start doesn't matter, or just it's solved problem. Maybe it's solved if it's asynchronous communication, but not every workflow, not every operation can be asynchronous, like log in, something like this. You need immediate response. You cannot proceed and say, I will check later. The same may be true for payment and something like this. So you can proceed, but you cannot finish the order if you don't have any payment, because it's difficult, if then the payment stacks, and then you say you send email that the order is more or less there, then you can do this, but it doesn't feel natural. So there are situations you need synchronous communication. You have this API-driven stuff, yeah, more or less synchronous request, synchronous response, and this is kind of the situation. So I don't want to talk too much about the cold start. You know this, how it happens. So what's important here, more or less, is just to understand that you have this init phase where this things is happening, and you have the full CPU access for 10 seconds for free. And this will become very, very important if we will be talking. So the full CPU access for free, but also only for managed Java versions, like 11, 17, 21. It's not if you are using Docker and then Java within that, it's not counted. So it should be managed Java. Yeah, this is one of the most important things that we will also more or less take more or less into the consideration. Probably know that there are Firecracker VMs come and go, and how the whole static stuff is working. So now let's look in some demo simple sample applications just to see what we are just talking about in terms of cold, but we will see also warm starts. So this is something similar we have on our work where we create products, and we are in the photo products product, create products, delete products, get product by ID, and more or less we have bunch of API gateway in front, bunch of lambdas, mostly synchronous, and we have DynamoDB there. And the most common setup we will start with, at least it's giving Lambda 1 GB of memory. We have default HTTP client. In case of Java, it's an Apache. This kind of application has 15 megabytes artifact size. This Java compilation option was considered as default until now. I will explain a bit. And I ran the experiment for 1 hour calling this function, and I reproduced more than 100 cold starts and 100,000 warm starts. With that kind of setup, if you have SNS, SQS, it will be similar. So what we will be seeing now, it's basically normal application. You see the cold starts. Yeah, it starts with more than 3 seconds. And I always look at the P90. It's most important one. And you see it's more than 3 seconds. Yeah, it's kind of a big one. So nobody will wait 3 seconds for login, or not everybody. Even you have only 1% of the cold starts, the situation is that it's too much. Yeah, and if you see the warm start, you will see that maximal values also can be about more than 1 second. The situation with that is that sometimes the things will be loaded if you are calling the warm, so the function itself. So this is not everything can be preloaded, or you can have a choice, and sometimes you preload the stuff and then it adds up, at least in the first invocation. So you have the cold starts, but the first invocation can also, which is the warm start, can take longer. And if you sum this up, it may be up to 5 seconds. And it's too much, basically, without doing anything. It's simply too much. If you have Python, JavaScript, you will be around half of the second. Yeah, and you have now another JavaScript runtime was released by AWS, which is, I think, in terms of cold starts, even better. Yeah, and under 1 second, that's okay, but it takes too much. But you see the warm starts, if you look into the P90, 7 milliseconds, it's okay. The warm start is okay for Java function. It's not about squeezing 1 millisecond of the warm start. Yeah, Luciano will be talking about trust. You will probably, that's normal values. So the Java is the very fast language, but the warm start, the cold start is significant. The whole JVM needs to go up and all that stuff. So we'll be talking about best practices, just how to reduce this stuff. Yeah, we'll be talking about AWS SnapStart, a bit of GraalVM, at least native image, and some general best practices, yeah, which are related to Java. So the first one is just initialize and then reuse dependencies quasi in this block outside of the Lambda function itself. It's called static initializer block. It will be called within initializing phase and the cold start phase. But at least if you will be doing this in the warm start phase, then it will be called each time then the function is called. In the cold start phase, it's one time. So the best thing is just to initialize all AWS clients what you are using. In my case, it was DynamoDB. If you're using SQS, something like this, or external communication, that's the best practice. Of course, you should set the variables, so the parameters that you already know. For example, the region that you are deploying, you know this. AWS can deduce it anyway, but it takes several milliseconds just to them, or several hundred milliseconds to find out in what region it's deployed. You generally know this. In many cases, it's only one region where you host the application. So simply pass it, it will be easier. So this is something that we'll call priming, and you need to think, can you prime and will it produce results? But with SnapStart, we will be talking about, it's a huge factor. So it's known that if you initialize the client, and for example, you do the first invocation towards DynamoDB, what's happening there that the objects, Java objects, needs to be serialized to JSON or going back, and this means that there is some JSON parser, Marshall, unmarshall, the names are serialized, deserialized, needs to be initialized. And this is one-time operation for the lifecycle of the Lambda function, only one time, but it may take up to 600-700 milliseconds. And this is something that's only the first call, so it can be okay that you put this out of your Lambda function to the static initializer block and fake this invocation. It only benefits you in terms of SnapStart always, but if you don't use that, it helps you if you have, for example, less memory than 1 gigabyte for your Lambda function, because in the static initializer block, you will get this 1 gigabyte for 10 seconds for free anyway. So you have more CPU cycle, you can speed up things. Yeah, your code will be ugly because you are faking invocation to DynamoDB in the static initializer block, and just like this, in this example, but it gives you more or less better performance. Your code is not looking very good, but at least it gives you some boost. So you are offloading something to the static initializer block, to the cold start phase, but it's then quicker than doing this in the warm start phase. And this was the reason why the warm start for max value was so big. I didn't do this. Yeah, but if I will kind of defer this to the static initializer block, then the cold start will be bigger, and the warm start will be then less. You need to think, is this something worth doing? You need to test. You need to see how much memory did you give for your function and all that stuff. But basically, people who know Java probably use Spring Boot, classical, or something, Spring applications, and they all use reflection and all this stuff, and this is something that you will not be doing with Lambda. It just takes too much time. It's more or less for web app-based applications, like you're using Tomcat and all that stuff. That start time is 5-6 seconds, and the container is running for months or for weeks. Then it's okay to use that stuff. You don't pay too much penalty. But for short-lived Lambda functions, all this stuff like reflection, runtime, bytecode generation, it will bite you, more or less. Yeah, it's just not applicable. So how to deal with that? And this is kind of this piece of technologies that AWS released on their own, AWS SnapStart. Yeah, this is something developed by them personally, and this is kind of where really you see how much brain power is there. And I also more or less wrote the article there. I covered that a lot, but also about the frameworks. I will be only shortly talking about how it's working. So basically, with the SnapStart, how you deal with Lambda functions is more or less broken into two parts. There will be things that will happen during the deployment phase, and then will be things that will be happen when you invoke the functions. Yeah, you see that this orange one, create microVM snapshots. So SnapStart is about creating snapshots during the deployment phase, and then more or less loading the snapshots during the invocation phase. And if you're now seeing that, you see more or less that this is Firecracker microVM snapshot. So the whole Firecracker microVM snapshot during the deployment phase. And then in invocation phase, you have restore snapshot, and you have some optional hooks we will be talking about. Yeah? And for these hooks, Lambda uses some CRaC API. We'll be also talking about this. So how it's is working. It's only more or less the very basic thing. During the deployment time, more or less the snapshot of the whole VM will be created, and then it will be encrypted and put into the tiered low latency cache. Tiered cache, if you use Docker, you also know that that will be stored in chunks, and these chunks can be updated and then loaded. Something very similar, and this is from then you load this during the invocation phase. Then basically, the snapshot will be loaded. So what's the at least assumption that the snapshot resume or loading and resume will take less than the cold start. Otherwise, it just doesn't make any sense. Yeah, so this is we will see the measurements, more or less. So basically, if you're in the Java space, maybe you knew about this CRaC project. Yeah, there is Java CRaC thing, kind of now very popular. AWS is doing something else, but I wanted to give you the overview and then what's the difference. So the CRaC is more or less a Linux project that is around more than 10 years and basically was created more or less to move containers around the VMs. Yeah, the same idea, more or less, yeah, doing some snapshots of the process and then bring it up on another one. Of course, there are challenges, open files, network connections. If you just have network connection open and you more or less do snapshot, then you might have problems. There are also time-based caches and all that stuff, because if you store value for 10 hours and then restore a snapshot 11 hours later, then the value might not be there. Something like this, so you need to think about this. But Firecracker VM is doing it a bit differently. And this is the difference that CRaC, in the classical form, saves the single process, and microVM's snapshot is snapshotting the whole running operating system. So more or less the whole VM. It has advantages. You don't need to care about file handles and all that stuff because they will be there, but there are drawbacks of synchronization and all that stuff. Yeah, so they are doing it a bit differently, and they completely implemented this because they are kind of AWS is owning Firecracker as a microVM, and they know how to deal with that stuff. So basically, AWS SnapStart is more or less about configuration. You decide on the Lambda function whether you would like it or not, and you simply configure it. Here you see in general configuration, you basically say yes to SnapStart. Yeah, you need to use aliases then. You cannot point to the latest version, but it's not very difficult. In case you have the SnapStart enabled, then in case you deploy your Lambda function, you will see something like this. This in orange that the snapshot will be taking. Of course, it then takes time, more time, because the snapshot taking, then storing this in the tiered cache, it takes time. Yeah, it takes, talking about 3 minutes. Between 2 or 3 minutes during the, more or less, you say SAM deploy, or something like the CloudFormation or Terraform deploy. It takes between 2 or 3 additional minutes having one Lambda with enabled SnapStart. If you have many Lambdas, then it happens in parallel, so it doesn't add too much additionally. So I had 10 functions, it took 15 seconds additionally. Yeah? So it's basically the factor, but yeah, this is more or less a bit UI UX. How you test it, we will be seeing. And in case you enable SnapStart and you have the invocation of the function, you see now you have this kind of restore report. You don't have the classical cold start, but you have the restore, which happens more or less in the initialization phase. It's kind of, you have different output in that you clearly see that the SnapStart is enabled, and this is something that you can prove. So you have also these hooks we will be talking about. They implementing CRaC API. So once again, people using Java maybe heard of CRaC. It's not about CRaC here. They only use CRaC API. We will be seeing that. Also, these hooks are optional, and it's more or less 2 methods that you can implement. So basically, if you use Java CRaC, the ideas are the same. The CRaC more or less stores or more or less creates snapshots of the processes. CRaC is based more or less upon this. This is kind of create GVM snapshot and then restore GVM snapshot. So if you use CRaC on your Spring applications outside of AWS, and CRaC alone is not working on Lambda. I tested this, they are not working, but basically you need Kubernetes Fargate, something like this, because the underlying system doesn't support CRaC, and you need special JVM which is CRaC enabled. For example, Coretta isn't. And so on, but basically the CRaC's idea was more or less that the time to first operation reduced. Yeah, this the same idea, but AWS don't use CRaC. They only use CRaC API. They don't use Creo. They use microVM snapshots, but just to give you the idea. So what is this CRaC API AWS is using? You need to implement this resource interface, which basically adds two methods. Before checkpoint, checkpoint is snapshotting. That's the same name, taking the set node, and after restore, if the invocation phase happens, you can put some logic in this after restore. And you need to register this. That's more or less the same line of code, core get global context register this. So where this might help, we talked about priming, by priming DynamoDB invocation that to warm up this JSON marshaller. And it's very convenient then if you're using SnapStart to do this in the before checkpoint phase, because it happens during the deployment. It doesn't take any time during the invocation. So you put more logic into this during deployment phase and pre-initialize something, and then this checkpoint or snapshot will be taken with pre-initialized classes, pre-initialized JSON marshaller, and you will save time with that if you have this. Not all applications use DynamoDB. You need to think, do you have to prime something? In this case, the call to DynamoDB is worth doing priming, and it's always the same. You can check some table, you can even check some metadata of the table. It's enough. It's simply to pre-warm this JSON marshaller. And this is technique called priming. You need to then put dependency to org CRaC to be able to do this. So yeah, there are some guides that you can read how this priming, there are some best practices how to do this. And the effect of priming is huge, especially if you have something to prime, you have SnapStart, if you can put this into before checkpoint so that it takes a bit longer during the deployment phase, but it occurs very rarely that you deploy. Yeah, then you have a huge benefits during the invocation phase. There is a great talk of Mike Danilov at KubeCon last year where he talked about SnapStart under the hood. I only talked a bit about this. He explained the ideas architecturally, what were the challenges, how they solved it. It's really, really cool. So once again, SnapStart, the name is AWS SnapStart. Maybe the idea is that the other runtimes will be supported, but basically only Java runtimes are currently supported, also managed runtime starting from 11, 17, 21. So once again, deployment takes two and a half until 3 minutes. Yeah? There are also situations that the snapshot will be deleted if the function is not invoked for 14 days. So it's not ideal if you are using some staging environment and don't do anything there, or you have functions that are really invoked rarely. Then you need to think about it. I raised the situation that it's not okay. If you call this function, you will, with SnapStart after 14 days, you will receive the error. In the background, this snapshotting is restarted again, which takes 3 minutes. So if you call it again, within 3 minutes, you will receive error, and you don't know why. So this is something that's really, I suggested that the normal call start without SnapStart will be kicked in if the snapshot is not there. I'm not interested in error. It can take longer, but it should work. We are currently discussing it. It's not up to me. But also, SnapStart currently doesn't work with provision concurrency with IRM architectures. Yeah, it's only standard x86 architecture. It's not working if you're using elastic file system. I don't use it with Lambda. I use S3, but in case you use it, it doesn't work, and the same as the ephemeral storage can only have default size. Now it can add up to 10 gigabytes and pay for it. It's only working with the standard one. So what could be this, some ideas, and I will show metrics. Next things will be just this priming adds additional code. You need to write repetitive code, and sometimes it's really good if that works out of the box. If AWS will somehow help you, there will be open source project that you don't deal with that. So I also said that the snapshot creation, the first Lambda invocation, it should be triggered differently and don't run into the errors. So now let's show this metrics. I showed you this warm and cold starts without SnapStart. Now let's see what does it bring. So alone by activating SnapStart, and this is in the middle. On the left, there is no SnapStart matrix. That's the cold start you see. And only by activating SnapStart, which is more or less checkbox, you see that the cold start is already going down. It's still, in P90, probably not then 3.5 seconds, but 2 seconds. But at least one checkbox and you are just 2 seconds. On the right, you see the effect of priming, in case you have something to prime, like this DynamoDB. And then you see at P90, you will be a bit above 1 second. This is significant. Yeah, this is significant, and it's worth doing. Yeah, it's just simply by checkboxing and doing some repetitive priming logic, you can bring this to 1 second more or less at P90. It's a bit more than Python, JavaScript, but it's not 3.5 seconds. It's just a huge advantage. This is also the metrics for the warm start, so that the execution of the function itself, you see it's more or less, so priming is more or less about cold start. You see that metrics are more or less comparable. Yeah, so it's interesting enough, I observed that the highest values with SnapStart will be lower, but it's because of the priming effect. It's just, I offload this more or less. So this was kind of the basics. So you can bring it in many situations with standard things up to 1 second, and I think it's okay. This makes Java accessible, but let's see what's possible more or less a bit more. So let's experiment a bit with, for example, Lambda memory settings. Yeah, so what I shared you was 1 gigabyte. This is the cold starts if across quarter of gigabyte until 2 gigabyte. Yeah, it's just factor of money. It depends on the performance. But what you see here, that the effect of SnapStart, it's more or less somewhere around 1 gigabyte. It's flattens. Yeah, you don't have such a gain. If you see here 1.5 gigabytes, it's dropped a bit. And if you will look into the warm start execution, so if you give Lambda more memory, you at least would like to see more speed up on the execution, the more processing power. Also, it's just a bit better on this higher P99, so, but on the normal stuff, it's. So I think with 1 gigabyte, it's okay to be with a SnapStart. In the more situation I tested, it could be a bit less or a bit more, but I don't see it's also just about money if you're assigning more, and just doesn't make any sense. This is the situation without SnapStart, I think. Yeah, this is now with SnapStart and priming, basically the same. You see it flattens more or less 1 gigabyte. This is the warm start with SnapStart without priming. Also more or less the same situation. Around 1 gigabyte, you have more or less the same numbers. And if you have SnapStart and priming, then basically you can also live with less than 1 gigabyte. You see the values are very, very close to each other. Starting at least 768 megabyte and so on. And SnapStart and priming here, warm starts, yeah, also comparable, more or less. So it's then up to you, but I also observed 1 gigabyte, it's a good choice generally to start with. So what I also tested was deployment artifact size. It's known the less the deployment artifact size is, the less the cold start. It's more or less the same. My question was, will it change with SnapStart? Does it, this restore of the whole microVM, does it matter how big the package is? And it's very, very interesting to see. I tested 3 use cases. The first one you can ignore. It's hello world application. Nobody writes it. It's not worth doing SnapStart. But I just tested between 15 megabyte medium and 50 big, just adding some AWS dependencies. And you see basically that this green one in the middle, it's lower, significantly lower than the orange one on the left. So the deployment size matters for all use cases, even with SnapStart and priming. So restoring the VM with a kind of bigger content, yeah, deployment packages somewhere, and the memory also takes time. It's not, you don't save too much with that. My initial feeling was that I will expect a bigger impact, so I can have a bigger package and then the cold start will remain more or less because it's about milliseconds. No, it's not. So the deployment package matters. So just that's why look what you are putting into your package. So just don't put dependencies that you are not using, even with SnapStart and with priming, and it all still matters. So for people knowing Java, I will maybe jump over. There are different compilations options. How to use this? You can pass it with environment variables. Just the variable name is Java tool options, and you can pass different stuff. It takes over. So the idea is this all compilation options from more or less using client compiler, server compiler, optimizing all that stuff. It was more or less developed for long-lived applications. So then Lambda, so the function can be optimized after 10,000 invocations. And then for long-lived application, it's okay. Then you have millions of invocations, it's optimized. But for Lambda function optimization, so you won't even have 10,000 invocations before the container will be more or less displaced. Yeah, so that's why spending CPU cycle on optimization, which will not kick in, may be counterproductive. So you don't, maybe it's not a good idea to more or less do this compilation, optimizations, and all this compiler stuff. And there are 5 levels of optimization. So basically, just not to say too much. So this server compilation, that's the highest thing, more or less, that's the application has the perfect performance long term. It's just not worth doing. This is stop at level 4. It's more or less server compilation. It's simply, yeah, you can more or less stop doing this. You have the highest numbers. You see these green ones. So basically, it's up to you whether to use default one, which is tiered compilation, some mixture, or you stop at level 1. This is where you a bit optimized after the client compilation, and then you don't do any further optimization because it costs you in the cold start CPU cycles and time. So basically this tiered, the red one, and the stop at level 1, this green one, which is near the red, these are the best choices. And it's up to you. My personal feeling was with tiered compilation in Java 21, you have better cold starts, but worse warm starts, or vice versa. But they are really, really, really close. So basically, you can use default one. You cannot provide these options. It will be then tiered compilation. It's okay, but server compilation doesn't make any sense. I also experimented with HTTP client. Yeah, when we are using it. For example, if you instantiate DynamoDB client, SNS client, SQS client, if you don't call this HTTP client stuff, then will be the default HTTP client anyway set, because it's HTTP communication with DynamoDB. Yeah? And in case of synchronous communication, it's Apache HTTP client, so you will using it behind the scenes. But AWS provides for synchronous communication to more clients. This is URL connection, which comes with also from Java community, and they also provide CRT client. Strange name, but it's also AWS own implementation of HTTP client. It's based on reflection, a lot of C code, if you look behind the scenes, but it's then up to you if you would like to use some other HTTP client, not the default one, then you need to set it. I just commented this out. These are 3 options, and the first one you don't even need to set it. It's by default. If you set other ones, you need to put the dependencies, like the below one is CRT client. So there are different pros and cons about this, but basically what's really visible is this yellow one, CRT, coming from AWS, provides really better cold start times for without using SnapStart or SnapStart, but without priming. When you use priming, it just doesn't matter too much. You see on the right one, the values are very close. Yeah, so with this SnapStart, you can leave the default. If you don't have anything to prime, then this CRT client from AWS provides the better performance. This is the cold start, and with the warm start, it's a bit different, but basically you see that the green one, default Apache, and this yellow one, they produce similar results. But for the cold start, you can switch and use CRT. There are also asynchronous clients. Yeah? So if you would like to have some kind of asynchronous communication, then you can instantiate, instead of DynamoDB client, you can instantiate DynamoDB async client. And then you can pass asynchronous HTTP clients. The default one is Neo. You don't need to do anything. It's by default. And this CRT, AWS implementation, has also asynchronous client. Yeah, both are available since 1 year, and you can pass both, but then you need to have this Java synchronous communication pattern with completable feature. Just doesn't matter, but then you will probably need to have some asynchronous communication. Also, maybe even until the front end, not to block. So it's up to you to decide whether you would like to use asynchronous communication itself. Also the same stuff, you need then to provide the dependency if you don't use this Neo. So these are my measurements. You see, for example, the same stuff. This AWS client, asynchronous client, its own performs really well without SnapStart or with SnapStart without priming, and the results are quite close with using SnapStart and priming, because you basically call DynamoDB one time, initializing this HTTP client in the before taking the snapshot. So they are really, really close from that point of view, and it's also expected. And the warm starts are basically comparable, but you see that the AWS CRT is superior there. So basically, it's up to you. AWS provides a recommendation. You probably don't see it very well what client to use, because, for example, you can tune this default Apache client much better. Yeah, you can provide caching and all that stuff. It's with the URL and AWS CRT. You have less options. I personally don't tune it anyway, to be honest. Yeah, so that's why it's just too much thinking in that. I see if the default configuration works, but basically, if you don't have priming, but then don't have something to prime, then use maybe CRT client if you have outside HTTP call at least, or something like this. So we basically talk through these SnapStarts options with compilation options, memory, package sizes, asynchronous communication. Of course, there are other options, not with SnapStart. This is this GraalVM. Probably people know in the Java space what it is. It's basically you add GraalVM compiler, which gives you the possibility to use ahead-of-time compilation. Yeah, normally with Java you have just-in-time compilation, but there is also an option to use ahead-of-time compilation, which works like during the packaging phase, everything should be packaged that will be used in the application. So everything that is reachable needs to be packaged, and then you can produce the native image of this, which is containing all that stuff, optimized. You don't have Java compiler there. It's optimized for the machine, more or less. And basically, GraalVM gives you an option, and they gives you the trade-offs, but you see this AOT, ahead-of-time compilation, low memory footprint, startup speed, small packaging. This is something related to serverless. So it's basically good to have this AOT, and that's why with that, the cold starts can be reduced significantly. So the situation is AWS doesn't provide managed GraalVM. Yeah, there is no option. Yeah, the question how we can put it, we have custom runtimes. And with custom runtimes, we can put our runtime, and basically we can put this GraalVM native image as a part of this custom runtime. It's basically a zip function which has the entry point like bootstrap file, and this bootstrap file should be GraalVM native image compilation. The situation is custom runtime only supports Linux, So that's why you need to compile for Linux. Yeah, GraalVM supports all, also Mac and Windows, but 5 minutes. But this is how you can do this. I tested this. I didn't release now this article, but basically what you see here is that this is the cold start, much lower. You are in the space between 5 and 700 milliseconds, not more, 1 second, and you see the memory, at least something between ½ gigabyte, starting from ½ gigabytes. With less memory, you can have very, very competitive cold start times, much below SnapStart, to be honest. And this is the warm starts. They are also better than without using native image. Yeah, but the warm starts are not the problems. These are also more or less the bigger value, P99.9 and max value. But with GraalVM, you have better options. Now this is more or less the comparison between SnapStart without SnapStart, SnapStart without priming, SnapStart with priming, and GraalVM native image. So you see that the whole thing for 1 gigabyte, just to have it comparable, Apache HTTP client, which is default, you see GraalVM native image has much better cold starts and doesn't require even memory. So you can go with 212, pay half less for Lambda function and have still nearly the same stuff. This is the warm start. They are also more or less even comparable across all of them. These are the biggest P numbers and all that stuff. Yeah, this basically I showed you, but the situation is, of course, GraalVM is not for free. It's powerful, has a lot of potential. It reduces cold start, but it has its challenges. Yeah, it's only Linux, so you need to think how to test this locally, or how to build this locally. And if you don't test locally, it's also okay. But the situation is here the same. You need to scale CI/CD on your own. SnapStart is checkbox, and everything. Snapshot taking, restore is managed by AWS. You don't need infrastructure. Building GraalVM native image also takes 3 minutes, comparable to taking snapshots for SnapStart, but it's then your hardware. If you're building too many and it takes 10 gigabytes sometimes to build this, and if you need to scale this up, it's up to you. Then, yeah, it's your burden, and yeah, you pay for initialization phase. It's not a big factor, but then you need to think about scaling. And of course, you need to think about, with GraalVM, not running into runtime issues. Yeah, because if you put something there per reflection, dynamically something will be loaded. And if it's not packaged, then you have a problem. You will have runtime error. That's why you need to include lots of JSON files, which classes need to be bundled together, that are basically will be loaded on runtime, more or less. This all your entity objects, that's all your Lambda functions, which will be instantiated runtime, because, yeah, so the class itself. So you need a bit more work, and yeah, at risk not putting everything. And sometimes you're at risk, you're using some open source project, which is not capable of GraalVM. It has a reflection, and you don't know this. That's why GraalVM, they put the list of libraries that are free to use with GraalVM, which are battle tested, that there is no reflection and something like this, or it's at least everything is configurable. So there's all this Micronaut, Quarkus, Spring, Helidon, all these bigger projects. They are tested, battle tested. They can be used with GraalVM, but sometimes you put some open source dependency. It has other dependencies. You don't control this, and then you have some runtime problem, even without noticing, because you're updating this to the merger. So this is another trade-off. So I won't be, because of time, won't be talking about proactive initialization, all that stuff. I also now writing the article about serverless and using data API, so using Aurora serverless without DynamoDB, and I'm now also started the series about, yeah, Spring Boot application on Lambda, so more or less the same, but using different, there are 5, 6 different ways to use Spring Boot, and many people use Spring Boot, and they are data centers or on EC2 would like to migrate, so that can be interesting. So maybe my personal advice is SnapStart is easier to use. It's checkbox. Yeah? So if it's okay to have 1 second cold start, go with that. Yeah? Especially if you can prime. Don't have this complexity of GraalVM native image. If you really need something like half of the second of the cold start time, just you need to squeeze every millisecond, and you would like to be on Lambda, only then look into the GraalVM native image, yeah? Because that complexity is additional complexity. Sometimes it's not worth half of the seconds. But it's more or less up to you. Look, can you prime? You can't prime, because without priming, you have bigger cold starts with SnapStart, but it's totally okay for GraalVM, just because they put everything together into the native image. So this is kind of the trade-off that I personally observed. Start with something that's simpler and it's managed for you. Yeah, and then look into that. So if you would like to engage with me, just you will find me. I am probably the only one with that surname in the world, besides my children and wife, but they are not active in this space currently. So thank you, and just try it out. I hope to see more people with Java. It's cool that the talk is selected, that at least the knowledge is spread in the community. I see that AWS missed a bit train in the last years, and that's why the community is more or less into the direction of Python and Node.js, and then it's difficult to convince people to migrate. It's happened also to us. We have a Java company, but we also started to write Lambdas with TypeScript, with Node.js runtime, because there have not been any solutions 2 years before. Yeah, and now we are just simply continuing more or less and experimenting. Yeah? And this is something, but there are lots of people having Spring Boot applications and would like to change. So thank you very much, and have a good rest day of the conference, which is 80% left. Yeah. Do you have any questions, or what questions do you have? I hope we have several seconds. I don't want to block the next speaker.
No, we have a coffee break for 15 minutes, so if someone has a question, just go ahead.
Yeah, Luciano. It was my personal idea 1.5 years ago that AWS will do this. But with doing SnapStart, they showed that I don't think they will support both. They invested too much into direction. They, as I told, there are really good people from the perspective of the Java compiler working on this microVM snapshot and restore. So I think they will continue with this. I personally see that they will maybe release SnapStart for .NET application or other languages having also this cold start problem. Yeah, it's basically also, as far as I know, Go is not perfect, but also others, like maybe, what will be really cool if they will provide SnapStart for custom runtimes. Then you can do GraalVM with that, and you can do Docker with that. Yeah, because Docker cold starts are the worst thing that I measured. Yeah, you cannot optimize, you don't have SnapStart there. If you use Docker with Java, you are left with 3.5 seconds without any chance currently. So my personal feeling, they will support SnapStart for custom runtimes and maybe selected managed runtimes like .NET.
Also, I mean, Graal adds the complexity of you have to have the custom runtime stuff. But the end is cheaper than actually running the solution is pricing, right?
It's more complexity. Pricing, GraalVM is more or less for free. Now there is a community edition, and even they are now more integrating into the normal GDK stuff. So it's for me, it's a complexity and unsurance what can happen on the runtime. Yeah, you need to unit test everything. You need to deploy. It's very difficult to build runtime, GraalVM runtime locally. You need so much memory there that you can't basically do it. You need CI/CD. You need to deploy, and only then you need to test that. Yeah, that you don't run into some runtime problems. And that can also happen with the SnapStart. It's a hugely complex piece of technology to have this microVM snapshot and then restore it. Many things can go wrong there as well. Yeah, we don't see this, but at least 1.5 years ago, as AWS released that, there have been problems runtime. Yeah? After they now have fixed that, but basically it can also go, things can go wrong for multiple reasons, but of course AWS controls completely the hardware. This is a Firecracker VM with the underneath hardware that AWS knows what to snapshot, what's important. Yeah.
I don't know about the Java libraries. I use not myself, but you said GraalVM is not free. Are AWS is charging for that, or the GraalVM itself is not?
No, GraalVM is free. The community edition is free. There is enterprise for peak performance. Then Oracle is charging, but you can use the community. It's not free in terms of it has complexity, but you can use for free completely. Yeah? So it's parallel stuff. You download the things and.
Okay, I think we'll wrap up there. And,
yeah, I'm here for the whole day, so you can
yes.
ask. You can keep asking questions. Thank you.